Warning: nitric acid is corrosive and oxidizing and may set nitrile gloves on fire. Nitrogen oxides are irritating and toxic. Chromium compounds are skin irritants. Wear vinyl gloves or no gloves at all when handling fuming nitric acid, and always wear a respirator. Hi guys, here is MIH. As I promised you guys, in this third episode of our green chemistry series, I'll make nitric acid without using any other acid and without producing any wasteful byproducts. We can do this by the thermal decomposition of chromium nitrate monohydrate. It decomposes between 80 C and 300 C, giving off various gaseous products such as water vapor, nitric acid, dinitrogen trioxide, and oxygen. Now, I know Nerd Rage has a similar video where he made nitric acid by heating copper nitrate. The mechanism is similar here, but copper nitrate is harder for me to obtain, and the copper oxide generated is less useful than the chromium oxide generated in our reaction. Anyways, I start by constructing our apparatus. It consists of a 500 ml conical flask with a silicone stopper, followed by a condenser, a collection bottle, and an exhaust gas scrubber filled with potassium hydroxide solution. Note that the condenser is a Graham condenser, where the cold water is supposed to flow in the outside jacket and the nitric acid in the inside tube, but I modified it to a Dimroth condenser, where the nitric acid vapor is led inside the jacket. This should lead to a higher condensation efficiency. I noticed that the flow rate of the cooling water was a little bit fast, and I quickly fixed it by connecting a resistance wire in series to the pump to lower its operation speed. Then, the flask is charged with 150 grams of chromium nitrate monohydrate and set up on the hot plate to heat. I didn't add a stir bar as my hot plate can reach temperatures high enough to demagnetize it. As the flask heats up, the chromium nitrate slowly melts in its own water of crystallization. Then it starts releasing some white fumes that the camera didn't pick up very well. The fumes are probably a mixture of water and nitric acid, as chromium nitrate starts decomposing at around 70 degrees C, well below the boiling point of water. Soon, the temperature in the flask shot up to 120 C, and a brown gas is seen in the flask, which is nitrogen dioxide. Some colorless liquid also started condensing in the condenser, which is water mixed with very small amounts of nitric acid. A few minutes later, the temperature rose to 200 C, which exceeds my thermometer's range, so it switched off. The nitrogen dioxide color wasn't as strong as before because the water vapor reacts with it to form nitric acid, which dissolves over and condenses in the condenser. If you look closely at the bottom of the condenser, you'll notice a small amount of colorless liquid, which is our nitric acid distillate. It didn't flow into the receiving flask because the exit tubing is higher than the liquid level, which is the only annoying thing you must face when modifying your condenser in this way. You get your distillates mixed up again before they can be collected separately. Around 10 minutes later, the nitrogen dioxide color builds up again, and our nitric acid distillate overflowed into our collection flask. The concentration of the nitric acid here is slowly increasing as less water distills out along with it, but since it is not very concentrated anyway, I chose to let all of them mix together and collect as one dilute nitric acid fraction that I can concentrate later. In the collection bottle, there are already around 15 milliliters of crystal clear dilute nitric acid. 15 minutes later, the nitrogen dioxide color in the condenser increased significantly, indicating that large amounts of nitric acid is distilling over at high concentrations. The receiving bottle was also filled with the brown haze, and the extra gas bubbles out of the exhaust trap. I switched my receiving bottle for a new one to collect the concentrated nitric acid. You can see that a lot of nitrogen dioxide is generated in this stage, so wear a respirator when changing the receiving bottle, and be fast with your movement. 5 minutes later, some slightly green nitric acid is collected in the receiving bottle. I assume the green color to be small amounts of chromium nitrate that aerosolized during the process and ended up in the acid, but I won't bother removing it. The exhaust tube is also filled with large amounts of nitrogen dioxide, so the alkali trap is very important. As the distillation progresses, the rate of distillate coming over slowed down a lot, so I decided to squeeze a bit of extra yield by adding water to the flask and distill the rest of the acid out that way. I emptied the nitric acid in the condenser by tilting it at an angle to let the acid flow into the receiving bottle, and in there we have around 40 milliliters of decently concentrated nitric acid. I swapped the receiving bottle and poured the concentrated nitric acid into a Teflon-lined plastic bottle for storage. You can see that it is still pouring out nitrogen dioxide, which indicates that it has a very high concentration. I then added around 30 ml of water to the flask, and as the water boils, it brings the remaining nitric acid and nitrogen dioxide with it, removing the brown color. After around half an hour, I turn off the heat and let the apparatus cool down. As the flask cools, a bunch of nitrogen dioxide appears in it again, and I hope to recover this as well. To do this, I attached another tube onto the silicone stopper, which connects with the pump on one end and leads deep into the flask on the other. I then turn the pump on and pump air through the flask, which rapidly pushes the nitrogen dioxide through the apparatus into the scrubber. The flow rate was too fast, and the scrubber cannot handle so much gas, so a lot of nitrogen dioxide leaked out. I fixed the problem by adding more water to the scrubber and attaching a plastic pipette head that has a bunch of holes on it. This will increase the contact area between the gas and the solution and increase the absorption efficiency. I continue purging air through the apparatus until no more nitrogen dioxide color can be seen, and then disassembled it. The silicone stopper was severely corroded by the nitric acid fumes, but that is to be expected. The black residue left in the flask is a mixture of chromium oxides, and it easily crumbles when I touch it with my gloss rod. The residue will be converted to potassium dichromate in the next video using green chemistry as well, so please check that out as soon as it is posted. I then boiled down the potassium hydroxide solution in the scrubber, and when I added sulfuric acid to it, it releases a bunch of nitrogen oxide fumes, confirming the presence of nitrite ions. I plan to recover sodium nitrite from this solution. Anyways, it is finally time to check our nitric acid product and determine its concentration. The dilute nitric acid weighs 51.25 grams and has a volume of 43.5 ml, indicating a density of 1.178 and a concentration of 29%. The concentrated acid weighs 58.07 grams and has a volume of 46 ml, indicating a density of 1.262 and a concentration of 42%. To be honest, I expected the dilute acid to be more dilute and the concentrated acid to be more concentrated. I think the problem is my modified condenser tends to mix the distillates and not fractionating them well. The total mass of nitric acid made is 39.25 grams, which corresponds to a yield of 55.4%. The yield may seem low, but it is rather normal for this reaction. I didn't distill everything to dryness, and there are large amounts of nitrogen oxides that were absorbed in the scrubber and thus not counted in the yield. In conclusion, I am rather satisfied with this reaction and how smoothly things went, and I'll process my remaining chromium nitrate in this way. Now, I finally prepared all three inorganic acids commonly used in amateur chemistry. Of course, the 3 acids series will not end here, and I'll continue posting new methods of making the acids. See you soon!